Right, in this short video we're going to analyse some sound with a piece of software called Audacity, which some of you might know, some students might know, especially if you're musicians. It's a sound recording software, but the beauty of it is, especially from a physics point of view, is that you can record the sound and analyse it by displaying it as a waveform on the screen like this. Now, what have I got to as a sound source? I have an iPhone with an app that is a tone generator. Now this, if I press play, that will play any frequency you want. So you can change the frequency. You can go high, you can go low. I'm going to leave it like that. So we'll start with a frequency of 591.6 Hertz. Now, the sound's going to be recorded with a desktop microphone like this. So if I place that quite close to the iPhone, that's a bit better. And it's going to record and analyse it with Audacity on the screen here. Okay, so first frequency to write down for you is 591.6 Hertz. So that means that the virtual speaker cone is doing 591 complete oscillations per second. Okay, right, now if we record this like this, so just get a quick burst, that'll do. Now let's analyse this. Okay, what do I want? I'll turn that off because that's mildly irritating. Now what I want to do, if I just highlight a small section and then zoom right in. Okay, we zoom right in, we can see that it's displayed, we can see the individual peaks and troughs there. Okay, now this is a graph. You might be thinking, well, sound is a longitudinal wave and this looks like a transverse. This is a graph. This is a graph of the sound intensity. Okay, right, now if we zoom right in, because what we want the time period, the exact time period. So we're going to go from here to here. Now the amount of time is, well, the time is shown across the top axis, as we can see. So it seems to be starting at 0.6030 and finishing at 0.6047, isn't it? Okay, so this is 45, 46, 47, 48, 49, 50. So first one, T1 is 0.6030, T2 0.6047. All right, we're going to subtract those and then take the reciprocal and see if it matches our frequency on the iPhone. Okay, right, let's do a couple more. So let's zoom right out again. Right, let's try a different frequency. Let's go for a higher frequency. .743 sounds nice. Okay, so let's give a quick burst of this. Okay, right, now I will stop that. Okay, might need to zoom in a bit here. All right, so let's just take a little section. Let's zoom in lengthways, but let's zoom in on the y-axis as well. Right, so there we have it. We want, again, the time period, don't we? So let's go from there to there. What sort of times are we looking at? Right, our T1 is looking like 0.3426. Our T2 is looking like 0.34 0.34. So let's ignore the whole seconds. So we just want 0.3434. No, hang on a minute. This is, so 35, 36, 37, 38, 39. Right. So 0.3439. Okay, that's our T2. Our T1 is 0.3426. Okay, so we just want the time between here. Right, let's do one more. Let's go for a lower frequency. 236. 236. Okay. 236.6 hertz. Okay. So already a much lower frequency. Let's record. Okay, that'll do. Just a quick burst. Press stop. Right, let's just change the. There you go. Right, take a quick section, and if we zoom right in. So again, we just want the time period, don't we? From there to there. Looks good. Right, your final T1s and T2s. Right, T2. So we've got, here we go, 5.9400. 01. I need to zoom in a bit more, don't I? Okay. Now, because we've got a lower frequency, we've got a much longer time period, haven't we? That's why we've got a different resolution in the times across the top. So let's zoom in. That was the same resolution, wasn't it? Now, as we can see, it's a longer wave, isn't it? Right. What do we got there? That is 5.9364. 5.9364 seconds. And our T2 is looking like, that looks like halfway between. So I'm going to go with 5.94065. Okay, I think that's halfway between 5.9406 and 5.9407. So let's go with 5.94065. Because I think that's halfway between. Well, there you go. There's your 3 sets of T1 and T2, and your 3 values of frequency on this. Let's see if they are in agreement. Right? All you need to do is do the calculation of F equals 1 over T. Thank you very much.